So we have enough student, 4, 5, 6, 7. I am the 7 one. Okay, let's start. So today, the meeting, I will go through how to design welded connection. Just to give you a reminder, what we covered last 2 meetings. The last 2 meetings covered if you have a member under the effect of tension or compression, whatever, I don't care, P ultimate. We learned how to figure out the required number of bolts needed to connect this member to something called gusset plate. And this gusset plate is already connected with something else, maybe a column, maybe another member or other members. That's fine, I don't care. But how to connect this member under the effect of P ultimate, tension or compression? How can we figure out the required number of bolts? First step, you have to determine what is the size of your bolt. Because based on the size, the diameter of your bolt, I can figure out the area bolt. Then I can figure out the design shear strength of one bolt equal, I think, 0.75 NFNV area bolt, as I remember. So once you get the design shear strength of one bolt, you can figure out the required number of bolts by dividing P ultimate by phi Rn, and make sure this number must be rounded up to integer number. And the last meeting also, we have some restrictions. Restriction about what? Restriction about the arrangement of your bolts. We decided that we have edge distance minimum. We cannot put our bolts behind this limit. And we have also minimum spacing between bolts, the minimum edge distance based on a table. And this table gives you a value based on the diameter of your bolt. Go back to the last meeting. And we have minimum spacing between bolts. This minimum spacing equals 3 diameter of the bolt. So if you maintain these requirements or these limits, you can select the best arrangement of your bolts. Keep in your mind also the required number of bolts must be even number if you put your arrangement like rows and columns, parallel arrangement. And this number can be odd number if you are using a staggered arrangement. Do you have any question regarding the bolted connection that we covered last meeting? If you have any question, go ahead and let me know. As always, I'm saying, you have to understand the concept of design, because if you understand the concept, you can adjust yourself with any change in the future. Keep in your mind, this is not this equation or this equation will never be the final. Maybe after 1 or 2 years, the standard will be changed. They will discover, for example, this constant is not a good estimation, 0.75. So they need to change it, or they need to change their total equation. That's fine. But you understand the concept. You understand the concept. The concept of design, you have a member under the effect of a force, and you have bolts. You can figure out the design strength of only one bolt. How? Using this expression. Then you need to divide the applied force by the shear design strength of one bolt to figure out the required number of bolts. Then you need to arrange these bolts, and you have limits. You need to maintain these limits. That's it. This is the concept of design. Today, we will have a different concept. We are using welded connection. We are using welded connections. I would like to show you these are bolted connections. These will be welded connection, and these are rivets. We are no longer covering rivets. But keep in your mind, this is the final product. Can you see? We have a member, and we have this member, and we have this member. These three members are connected together here using welded connection. These are the shapes of your welded connection. Can you see this line? This line represents the welding. Represent the welding. That makes sense? So you don't need to make holes. You don't need to make holes in the member to put your bolts. That means this is the reason why area gross equal area net if you are using welded connection. Can you see here? The member is area gross. The full member is already there in the connection. No subtraction, no holes, no loses material. This is the reason why area gross equal area net if you have welded connection. So if you look to this truss, we have a member, we have another member, we have another member, another member, another member, all of them connected together by gusset plate, and each connection is called welded connection. We have different types of welding. We have fillet weld, will be covered in this course. We have groove weld, we have plug and slot weld. We have different types, but I will not go through all of them. I will just explain what is the main difference between all of them. Fillet weld, you have right angle between the two surfaces. So assume we have this plate and we have this plate. So we have right angle in between this surface and this surface. So I will fill this right angle with welding, and this welding is extended parallel to the two surfaces. If you would like to show you more, here you go, this one. So we have this plate, which is in parallel position, and we have this plate, which is in vertical position. Between the two plates, we have here right angle along this length. I will fill this right angle with welding. In this case, it's called fillet weld. Just put your vertical member, your horizontal member, and with your machine of welding, you can fill this right angle with welding. It will be called fillet weld. That makes sense? That's it. This guy with his machine, he will fill the right angle between the two surfaces. And that's all. The second type of welding is called groove weld. Groove weld, you need to create, we have this one and this one. So the two plates will be welded head to head. I will do groove here. I will remove the steel material at the two edges, and then I will fill this groove with weld. That makes sense? So you need first to create groove. You need to remove material from steel, and then you need to fill this groove that you created by weld. Keep in your mind, in the first one, you need to put your steel plate like this, and the second steel plate like this, to create this right angle and this right angle. So you can put your welding, I'm sorry, between the two surfaces. But for the second one, which is groove weld, you don't need to put the two plates over each other. You can put them head to head like this, and then you can create your groove, remove this edge and remove this edge, and then fill this groove with weld. That makes sense? That makes sense. The third type of welding is called plug and slot weld. For the first plate, I will create a hole. Hey, wait. If you create a hole, that means your area gross will not equal area net. Wait just a moment. Once you create this hole, I will fill it with weld. So the weld will contact the lower plate and will fill this hole. That means your area gross is still equal area net, because you created a hole at the same time you filled it with a material related to the welding. Sometimes your hole is a circle, sometimes your hole looks like a slot, like this one. Once you filled this slot with welding, keep in your mind the weld will contact the lower plate. At the same time, you are filling the lower slot in the upper plate. So you are connecting between the two using slot weld. That makes sense? So we tried to understand that we have different types of weld, different techniques. The simplest one, the easiest one to use is the first one, fillet weld. You don't need to do anything, just put your plate and start to weld. Unfortunately, the second one, you need to create something first. The third one, you need to create something first and then using your welding machine. But the first one, go ahead and put your welding, that's all. This one, this guy coming with the machine, welding machine, it's very dangerous. Don't try it if you don't have any experience. I tried it one time before and I shocked. I have been shocked, unfortunately, but I still alive. So welding, using a welding machine and the type of welding, fillet weld, is the most easy and the simplest way to connect two members. Before starting to talk about the minimum and the maximum, I would like to show you something very important. This slide is very important and will show you something. We have few parameters. The first one, between this angle or this surface and this surface, we have right angle. We will fill this right angle with welding. Your welding looks like a curve. We cannot create a line. It's a curve. But anyway, keep in your mind, we have this distance and this distance, which is equal W. This W represents something called weld distance. Weld distance. If you have this horizontal surface and this vertical surface, you will fill this right angle with welding. That means you will cover this little lens, excuse me, and this little lens. The two lenses are equal, W. The two lenses are equal. This lens or this W is called weld distance. Weld distance. We have another parameter, is this lens. Can you see? This lens, L, which is called the weld lens. Guys, keep in your mind, if you go back to this picture, this is the length of your weld. You will ask yourself, why I did not stop welding at this limit. Why I put the welding for this length? This is the question. This is your design. This is the final product of your solution. How can we figure out this length? That means I'm gonna assume weld distance. I will ask the technician, hey guys, please, when you are welding, make sure this distance, for example, equal 1/4 inch. And this distance equal 1/4 inch. Based on your assumption, I can tell you based on the design, what is the length of your welding. You need to stop welding after a length equal, for example, 4 inch. If you did your welding like this, it will be enough to support the applied load. But we need to understand something else. Yes, we have W, which is called welding distance, and we have W, but we have here this distance, which is called root, or can be called welding size. I remember one of the questions in the PE exam, just asking for what is the welding size. So please be careful about this concept. This horizontal distance is not the welding size. This vertical distance is not the welding size. The welding size is the perpendicular distance, and this perpendicular distance in this triangle equal W cosine 45 degrees. So, for example, if you have welding between these two surfaces, and your welding looks like this, and this horizontal distance 1/4 inch, and this vertical distance 1/4 inch, I can say W equal 1/4 inch, and this W is called weld distance. But we have something called weld size. The weld size equal W cosine 45 degrees. So 1/4 inch times cosine 45 degrees, I can find the weld size. If you multiply the weld size, W cosine 45, by the length of your weld, which is L, you can find something called area welding effective, area WE. If you multiply this area WE by something called FNW, you can get FNW. Do you have any question? Guys, do you have question? Okay. So if you multiply this area WE by FNW, I will show you what is the meaning of FNW. You can find the nominal strength. This is the nominal strength of your welded connection. So you need to multiply this Rn by phi to get the design strength. And you need to make sure your P ultimate is smaller than or equal phi Rn. That makes sense? Your phi equal 0.75. Your Rn equal FNW area WE. Area WE equal the welding size, which is W cosine 45 degree time length. FNW based on the type of the welding material. I'm not sure if you have experience about this or not, but these are called welding rods. And we have different types. We have different types, which is called filler metal. We have different classification. Sometimes we have classification like 60, 70, 80, 90, 100, 110, 120 KSI. So the value of FNW based on EISC equal, this is the value of FNW, this is the one we are looking for, equal 0.6 times FEXX. This value of FEXX is the strength of your electrode, of your welding rod. So if you go to Lowe's and you are asking for these rods, the question is, what is the classification? What is the category? If you look to these numbers, you will find this one is 70. This one is 70. So the value of FEXX is 70. Go ahead and multiply it by 0.6. You can get this value for D2. Once you get this value for D2, put it here for D2. And what is the area W effective? You can find the Rn, multiply it by 0.75. You can get the design strength of your welded connection. Make sure your P ultimate is smaller. If it's not, it's unsafe. Did you understand the concept of welded connection? It's very easy. Very easy. Very easy. So we have two different types of problem. The first one, everything is given, and we need to figure out phi Rn, and we need to make sure your P ultimate is smaller than or equal phi Rn to say, hey, it's safe, or it's unsafe. The second one, we are looking for L, the weld length, and nothing is given. Nothing is given in your problem. Just only we have P ultimate and we need to design the connection. That's it. So you need to assume everything and find the final length of your welding. So you need to assume the weld distance first. W. You can assume it. How much? 1 inch, 2 inch, quarter inch, half inch. We have a table here to help you to assume the minimum welding size. This one will not help you to figure out the welding distance. No, it will help you to assume W cosine 45, which is called weld size, the whole expression. So we can assume it 1/8, 3/16, 1/4, 5/16. These are the minimum you can assume. Which one I'm gonna use? This one or this one or this one or this one, based on the thickness of the plates you are connecting them together. For example, if we have this plate with thickness ½ inch, and we have this plate with thickness 3/4 inch, we need to connect the two plates together. What is the minimum welding size I can assume? Okay, go ahead and use the minimum thickness. If the two thickness are different for this plate and this plate, go ahead and use the thinner one. The thinner one is 1/2 inch. So if your thickness between 1/4 and 1/2 inch, guys, do you hear me? Okay, because I received a message that my internet is interrupted. Anyway, so your thickness is something between 1/4 and 1/2. So I can assume the minimum welding size 3/16. For example, if you have plate with thickness 3/4 inch, and another plate with thickness 1 inch. So I need to put fillet welding between the two plates to connect them. So I will use which thickness I'm gonna use? I'm gonna use the thickness of the thinner plate or the thinner element. So I'm gonna use 3/4. 3/4 means you are in this category. Over 1 inch thickness to 3/4 inch thickness. That means I'm gonna assume the minimum assumption can be 1/4 inch of your welding size. That makes sense? So this table will help you to assume the minimum. You cannot go below this element or this size. I'm sorry, this size. We have here maximum because I'm telling you this is the minimum. So you can assume something bigger, but bigger until what? We have maximum size. We cannot exceed this size. I'm telling you something related to AISC, American Institute for Steel Construction, based on the standard. So along edges of material less than 1/4 inch, if the thickness of these plates is 1/4 inch, make sure your welding size not greater than the thickness of the material. You cannot assume your welding size something greater than the thickness of the thinner plate. If the thickness of the material is 1/4 or 1/4 inch and more, no greater than the thickness of the material minus 1/16 inch. My recommendation, I'm gonna assume the minimum and will go through or will start from this assumption. I will not go to assume something bigger to put myself in this situation. I highly recommend, excuse me, to start with the minimum assumption. Let me do some example here. We have 2 examples. Let's start with the first one. The first one, everything is given. Everything is given. All information you need is given. The length of your welding equal 4 inch. Actually, it's not 4, but the length right now on the connection is given 4. And the welding size is given 3/16 inch. And the type of electrodes is given. And we need to figure out what is the design strength of this connection. What is the value of ARN? That's it. And then if B ultimate is given, I can make a comparison. If B ultimate is smaller than or equal ARN, I can say it's safe. Something else, it will be unsafe. So as you know, one of the philosophy of design, you can assume and then find the design strengths and then make this comparison to make sure your assumption is safe. This is one of the philosophy of design. Okay, let's start. The value of Rn, do you remember what was the value of Rn? Equal F NW time area welding effective. If you go back here, the value of Rn equal FNW time area welding effective. Let's start with the area welding effective. Equal the length of your welding time the size of weld. Size of weld is given here 3/16 inch. Anybody in this room can tell me what is the length of your welding? Any help? What is the length? What is the length of your weld? For any other answer? Eight. Any other answer? The length of your welding will be 8. Why? Let me explain it here. If your member like this, and you put only welding on this side equal 4, so the length of your welding will be 4. But you put also welding on the other side. So I have 4 and another 4. The total length of your welding is 8 inch at this moment. Both of them will support the applied load. That makes sense? So I did not mean by the length of your welding is the geometrical length. No. How much length or how long length you applied at this connection. I put welding here with length 4. I put welding here with length 4. So that the total length of welding equal 8. Be careful. Be careful about this concept. Then I can figure out the area welding effective 8 times 3/16 equal 1.5 inch square. FNW equal 0.6 FEXX. Can you go back here? FNW equal 0.6 FEXX. What type of electrodes you used? E70. So 0.6 times 70 equal 42. So go back and put the value of FNW 42, the value of area W effective 1.5. I can figure out the value of Rn 63. Keep. But I need the design strength. This value is the nominal strength. If you would like to get the design strength, I have to multiply Rn by phi. Your value of phi based on AISCC equal 0.75. So I will multiply 0.75 times 63. Your value will be 47.25 kip. This is called the design strength of this welded connection. If P ultimate is given in this member from RISA or whatever, I can make a comparison between P ultimate and the phi Rn and make sure your P ultimate is smaller or equal at least to make it safe. Any question so far? We have another example. And once we did this example, that's enough. And no need to cover the remaining part. It's not a big deal. In this one, the type of electrodes is given and the value of B ultimate can be determined. For example, dead load is given, live load is given. So I can say B ultimate equal 1.2 dead plus 1.6 live. So your P ultimate will be 56.8. The problem is asking to figure out what is the weld length required to support this connection between this member, which is angle 6 by 6 by 1/2. This one is angle 6 by 6 by 1/2. And we need to put welding between this gusset plate with a thickness 3/8 and this angle, which is 6 by 6 by 1/2. First step, I will assume, so this one B ultimate is given and everything is missing, and we are looking for L. I will assume the weld size. I have question. The weld will be done between this plate with a thickness 3/8 and this angle with a thickness 1/2 inch. How did you know it's a half? It's not a good question, because 6 by 6 by 1/2, the first 6 and the second 6, the lenses of your legs, not your legs, the legs of your angle. And 1/2 is the thickness of this leg. So this one had a thickness 1/2, this one had a thickness, the plate had a thickness 3/8. Which one is thinner? Which one is the thinner? I think 3/8. Based on the 3/8, I can assume the minimum weld size. I can go back to this table. If your minimum or thinner part is 3/8, I think 3/8 something in between here. So the minimum welding length can be, welding size can be assumed 3/16. So I will assume the minimum weld size 3/16. If you assume the 8 4/16, that's fine. 5/16, that's fine. 6/16, 8/16, all of them, that's fine. But make sure don't assume something bigger than the maximum size. To avoid this problem, go ahead and use the minimum. Okay? So one more time, go ahead and find out what is the thickness of the first part, what is the thickness of the second part. Then go ahead and use the minimum, the smaller, which is called the thinner part. The thinner is 3/8. I will go to this table based on 3/8 inch thickness, which is between 1/4 and 1/2. That means the minimum welding size can be 3/16. So the area weld effective, which equal the length by weld size. The length is unknown, the weld size is assumed 3/16 inch. So your value will be 3/16 times L. Looks good. So far, looks good. FNW equal 0.6 FEXX. 0.6. The type of electrode is E80. So this FEXX will be 80. Your value will be 48 KSI. And your phi equal 0.75. So the design strength of the welded connection, which is phi Rn, equal 0.75. 48 times 3/16 L. Hey, we still have L unknown. That's fine, no problem. Go ahead and simplify this expression. 0.75 times 48 times 3/16. Your value equal 6.75 L. L is the required, is the length of the weld. Hey, to make sure your connection is safe, your B ultimate must be smaller than or equal phi Rn. At least P ultimate equal phi Rn. This is the minimum we can obtain. B ultimate 56.8. Phi Rn as a function of L equal 6.75 L. Can you tell me what is the minimum length of weld? I can tell you. Eight 0.4 inch. Then you need to tell the technician, the welding technician, hey, the minimum size or the size of weld will be 3/8 with the length equal 8.4. I have another question, and please everybody pay attention. This is the final answer. I'm looking for the weld length, and you answered the question. The minimum length cannot be smaller than 8.4. You can assume 8.9, that's fine. 8.5, that's fine. 10, that's fine, but not less than 8.5, 8.4, because you assumed the minimum condition that B ultimate equals the design strength. My question is, I will assume I'm gonna use this length, 8.4. Anybody can tell me I will weld here how much and here how much? The length based on the calculation 8.4. So do you think I will put here 8.4 and here 8.4? Thank you. Yes, I will put here have this value 4.8, 4.2, and this one 4.2 inch. So this one is the total weld length. So this length plus this length equal 8.4. So after you are done with your problem, you need to sketch your connection and put the weld with the final length. So these are the common two types of welding connection. You can assume everything and define the design strengths and make comparison to make sure it's safe or unsafe. Or you can assume only the size of the weld and then you can make your length is unknown and wait to the final step to find out your length. And keep in your mind, this is the total length. So if you put your welding in this side and this side, so this length plus this one must equal the required length. Do you have any question? Do you have any question? Any question so far?